Hello everyone, Zen Programmer here. Today we're tackling the big question on everyone's mind. Will AI replace data scientists? Spoiler alert, the answer is a resounding no. However, AI is undoubtedly transforming our role. We'll explore how AI is enhancing our capabilities, automating routine tasks, and how this opens up exciting new opportunities for us to dive deeper into strategic, high-impact work. So, let's get into it. As data scientists, we're witnessing the dawn of a new era in data science powered by AI. Automation is becoming a major factor in reducing time spent on repetitive tasks like data preprocessing, feature engineering, and even model selection. But instead of replacing us, AI is augmenting our capabilities. It's a tool that accelerates our workflow, but it's up to us to interpret, guide, and customize the solutions. The future is bright, and we're in control of steering this ship. Let's look at the ways AI is assisting us in the data science process. First, AI tools are excellent at automating tedious tasks. For example, data cleaning is one of the most time-consuming aspects of data science. Tools like Trifactor and OpenRefine use AI to detect and suggest fixes for inconsistencies, missing values, and outliers. Moving on to exploratory data analysis, EDA, AI tools like Pandas Profiling and SuiteViz can generate a full set of visualizations and summary statistics within minutes, allowing us to quickly get a feel for the dataset and focus on deeper analysis. Lastly, AutoML frameworks like H2O.ai, Google AutoML, and Autosclern can automatically train and optimize models, handling hyperparameter tuning and feature engineering for us. This means that instead of spending hours building baseline models, we now have more time for refining them and tailoring them to our unique business needs. Let's dive deeper into the specific tasks AI is automating. Data pre-processing is now much faster with AI-assisted tools. These tools not only clean the data, but also identify feature importance and suggest transformations for the most relevant variables. For EDA, AI takes over generating basic visualizations, scatter plots, histograms, correlations, which gives us an immediate overview of the data structure and relationships. And let's talk about AutoML. Platforms like DataRobot, TPOT, and Google AutoML automate the model building process by selecting the right algorithms, tuning hyperparameters, and evaluating multiple models with cross-validation. This doesn't eliminate our role, but rather streamlines it, letting us focus on model refinement and evaluation. While AI is an incredible tool, it has its limitations. Domain expertise is still irreplaceable. AI might detect a pattern in the data, but it can't understand the business context behind that pattern. For example, AI might identify that a customer is likely to churn, but it won't be able to tell you the specific cause, like a change in customer service policies or an external market shift. Furthermore, AI struggles with distinguishing correlation from causation. A model might find correlations between two variables, but it won't know if one causes the other. That's where our understanding of the business problem is essential in crafting meaningful insights. AI also lacks the ability to define tailored success metrics for a business. For instance, while AI can measure general model performance using accuracy or AUC, we need to define success in terms that matter to the business, like ROI, customer satisfaction, or operational efficiency. This is where we truly shine as data scientists. Human intuition is irreplaceable. We understand the nuances of the problem, whether it's a specific market trend or how certain features might interact in a model. We can assess whether the data makes sense in a broader context or if there are external factors that AI might miss. A simple example is a model predicting sales, where an AI might find a strong correlation with a weather pattern, but it takes a human to understand that the correlation is because of a seasonal event affecting purchasing behavior, not just weather. Our ability to think critically and creatively is what makes us indispensable in this AI-enhanced world. As AI helps automate certain tasks, our role is shifting towards data strategy and architecture. We are the architects behind the systems that store, process, and transform data. We design scalable and secure data pipelines that ensure data flows seamlessly from various sources into analytic platforms like Snowflake, AWS S3, or Google BigQuery. We are responsible for integrating diverse data sources, applying governance standards, and ensuring that data is clean, consistent, and usable. Beyond storage, we architect solutions that enable organizations to leverage this data effectively, building analytics infrastructures that scale and adapt to business needs. These tasks are too complex for AI to fully automate, and they require human expertise in system design, cloud technologies, and data management practices. AI models, while powerful, can also perpetuate biases. Bias in AI arises when the training data reflects historical biases or lacks diversity. For example, a facial recognition system trained on predominantly Caucasian faces will have difficulty accurately identifying people from Africa. We can implement techniques like fairness constraints and adversarial testing to ensure our models are unbiased. Additionally, we ensure that our models are interpretable, allowing stakeholders to trust and understand the decision-making process. With data privacy laws becoming stricter worldwide, compliance has become a crucial aspect of our work. AI tools can process vast amounts of data, but they need to be handled within regulatory frameworks like GDPR, CCPA, or HIPAA. As data scientists, we ensure that data is collected, processed, and stored in compliance with these laws. For example, we implement data anonymization techniques to protect personal data, set up audit trails for transparency, and manage data access using role-based access control, RBAC. These are responsibilities that require our in-depth knowledge of both the technical and legal landscapes. With AI and no-code tools making analytics more accessible, we're seeing the rise of citizen data scientists, individuals who can perform basic analysis without formal training. This is empowering people across organizations to make data-driven decisions, but it also comes with challenges. Citizen data scientists may use tools like Tableau with GPT-powered integrations or Excel with advanced functions, but these solutions might lack depth and rigor. This is where we come in. We ensure that the insights they generate are robust, statistically sound, and actionable. Our role is to guide them in the right direction, making sure their analysis supports strategic decision-making. In many industries, AI is great for automating simple tasks, but complex problems require deep expertise. In healthcare, for instance, predicting patient outcomes involves nuanced models that consider not only medical data, but also behavioral and socio-economic factors. In finance, risk models must account for ever-changing market conditions and regulatory impacts. AI cannot replace our role in understanding these complex, domain-specific challenges. We work with domain experts to tailor models and ensure they deliver actionable, reliable insights in these complex problem spaces. Building models is just part of the journey. We are responsible for deploying, monitoring, and maintaining these models in production environments. The real work begins after a model is deployed, ensuring it integrates smoothly into the business workflow. We manage ML ops, setting up continuous integration and deployment pipelines with tools like Kubeflow or MLflow. Monitor models for performance drift using model monitoring tools and perform retraining when necessary. This ensures that models continue to perform accurately over time, adapting to new data and changing conditions. AI can generate numbers and visualizations, but we are the storytellers who translate that data into actionable insights. Data storytelling involves not only creating effective visualizations, but also framing the insights in a way that resonates with business leaders. Whether it's an interactive dashboard or a simple chart, we craft a narrative around the data, highlighting key trends and offering recommendations. This ability to communicate the why behind the numbers is what differentiates us from AI. Our role as data scientists is evolving. We're moving from routine tasks to strategic impact. As AI automates more basic tasks, we're freed up to work on complex problem solving, advanced analytics, and interdisciplinary collaboration. We're becoming trusted advisors within our organizations, collaborating with leaders across departments to guide data-driven strategies. In essence, our role is evolving into one of leadership and innovation, empowered by AI. So, will AI replace data scientists? Absolutely not. Instead, AI is enhancing our work, automating the mundane so we can focus on the high-value tasks. The future of data science is collaborative, us and AI working side by side. With AI handling the heavy lifting, we have more opportunities to innovate, lead, and shape the future of industries. Let's embrace AI, harness its power, and continue driving the future of data science forward. Thank you. This is Zen Programmer. I'll see you next time.